Hi all, I'm Grishma and you are watching my channel G Tutorial. In previous class we have covered the singletone and multitone modulation in AM. In today's class, let us discuss some questions based on this. First question is, in amplitude modulation, which signal amplitude vary? From the definition of amplitude modulation, we are clear that it is the amplitude of the carrier signal which is varying. So the answer is carrier signal. Next question. In the following equation, S of t is equal to AC into 1 plus k m of t cos 2 pi f ct. The constant k is called. So it is clear that this is the equation of amplitude modulation, and so here the constant term k denotes the amplitude sensitivity. Next question. In the following equation, S of t is equal to AC into 1 plus k m of t cos 2 pi f ct. The value of modulus of k into m of t is greater than 1. Then the modulated signal is. The value k into m of t is actually mu, which we call modulation index. If the value of modulation index is greater than 1, then it is called overmodulation. So the answer to the question is overmodulated signal. Next question. To view the modulated signal property, what must be the condition? The condition is that the carrier signal frequency should be very much greater than the message signal frequency. That is, Fc is very greater than Fm. Next question. In the spectrum of AM, what is the difference between upper and lower frequencies at positive frequency side? If you are plotting the spectrum of AM, and at the positive frequency side the figure is like this. Fc is the center frequency. The maximum to the upper side band is Fc plus Fm, and the lower side band is Fc minus Fm. And we are asked to find what is the difference between the upper and lower frequencies at this positive frequency side. So upper frequency is Fc plus Fm minus Fc minus Fm, which is the lower side. So minus of Fc, minus into minus is plus Fm. So Fc and Fc get cancelled. Fm plus Fm is 2Fm. So the difference between upper and lower frequencies at positive frequency side is 2 times Fm. Next question. What is the transmission bandwidth of AM waveform? Transmission bandwidth of AM waveform is twice the maximum frequency contained in it. That is twice the maximum frequency of the message signal contained in it. This is what we have done in the previous question. We have found it as 2Fm. This is actually the bandwidth. So in this question the correct answer is the transmission bandwidth is equal to option D, equal to double of the message signal frequencies. That is, bandwidth is equal to 2 times Fm. Now let us move on to the next question. This is the next question. The transmission bandwidth of AM wave is 2Fm. Which of the following is then correct? The correct is option C, that is Fc should be greater than Fm. If transmission bandwidth is twice the message signal frequency, then carrier frequency should always be greater than the message signal frequency. Next question. What is the carrier frequency after modulation? The carrier frequency does not have any change after amplitude modulation. It is only the amplitude of the carrier which is changing. So after amplitude modulation, the carrier frequency is Fc itself. So Fc is the answer. Next question. In the spectrum of AM wave, the lower and upper frequencies are equal. Then what is the relation between Fm and Fc? In this question, it is mentioned that the upper and lower frequency both are equal. Then what is the relation between Fc and Fm? Which is actually Fm is equal to Fc. That is, option D is the correct answer. If upper and lower frequencies coincide, it coincides with the center frequency. So Fc is equal to F. Next question. What is the need of frequency multiplexing in communication? Multiplexing means transmitting different signals through the same channel at a time. So the need of frequency multiplexing is actually option A, to transmit several different signals through single communication channel. We are able to transmit different signals through the single channel. Next question. For transmitting different signals through single communication channel, what is the technique used? Answer is frequency multiplexing. Through multiplexing, different signals can be transmitted through single communication channel. Next question. In frequency multiplexing, this is not question, you can just note it down, it is a short note. In frequency multiplexing, the shifting of frequency should be done without overlapping. Next question. For transmitting the 300 Hz frequency signal, what is the height of the antenna required? We have learned that the height of antenna should be 1/4 of the wavelength of the signal to be transmitted. Here we are given the frequency of the signal. So let us relate the frequency with wavelength of the signal. Only after finding the wavelength we can find the height of the antenna. We know that the formula connecting wavelength and frequency of the signal is lambda is equal to c by f, where c is the velocity of light. C is equal to 3 into 10 raised to 8 meter per second, and we are given the frequency of the signal transmitted is 300 Hz. So substituting for c and f, we will get the value of lambda as 10 raised to 6 meters. Now we can find the height of antenna. Height of antenna is lambda by 4. So 10 raised to 6 by 4, which is 250 kilometer. Next question. The message signal m of t is multiplied with carrier signal c of t is equal to ac cos 2 pi fct. Then what is the amplitude of the carrier signal after modulation? It is the amplitude of the carrier which is varied in AM. So the value of amplitude of AC after modulation is AC into 1 plus m of t. That is option A is the correct answer. Next question. The spectrum of AM contains the following frequencies. After modulation, the modulated signal contains carrier frequency, upper sideband frequency and lower sideband frequency. So option D is the correct answer. Next question. The carrier signal with frequency 10 MHz is amplitude modulated by a message signal of frequency 100 kHz. Then what are the sideband frequencies? Here we are given the carrier signal frequency, the message signal frequency, and we are asked to find the upper sideband and lower sideband frequencies. The options we can check the options. The options are given in terms of megahertz. So we need to convert the value given in kilohertz to megahertz. Here the message signal frequency is 100 kilohertz. So let us first convert it in terms of megahertz. 100 kilohertz is 100 into 10 raised to 3 hertz, which is actually 0.1 megahertz. 10 raised to 6 hertz is 1 megahertz. So 0.1 megahertz is 100 kilohertz. Now we can find the upper sideband frequency and lower sideband frequency. Upper sideband frequency is carrier frequency plus message signal frequency, that is FC plus FM. FC is given as 10 megahertz and we have found that FM is 0.1. So 10 plus 0.1, which is 10.1 megahertz, and the lower sideband frequency is FC minus FM, that is 10 minus 0.1, that is 9.9 megahertz. So the correct option is option C. Next question. The message signal is amplitude modulated with a depth of 60%. Then what is the carrier power of modulated wave? If the total power is 2 kilowatt, this is the first question. Here we are given that the signal is amplitude modulated with depth 60%. We have studied what is meant by depth of modulation. when the modulation index is expressed in terms of percentage, it is called depth of modulation, that is mu into 100. So if the depth of modulation is given, we can find the value of mu, that is modulation index. Mu is equal to 60 by 100, that is 0.6. And we are given the total power as 2 kilowatt. We are asked to find the carrier power. So we know that the formula of transmitter power PT is equal to carrier power PC into 1 plus mu square by 2. We are having the value of total power or transmitted power as 2 kilowatt. So 2 kilowatt is 2000 watt. So let us substitute for PT and mu. PT is 2000 is equal to PC into 1 plus value of mu is 0.6 square by 2. On solving, we will get the value of carrier power as 1.694 kilowatt. Next question is, if the total power is 1 kilowatt, what is the carrier power? This is similar to the first question. Here the total transmitter power is 1000. So 1000 is equal to PC into 1 plus 0.6 square by 2. On solving, we will get the value of PC as 847.45 watts. Next question. A 2 kilowatt carrier is modulated to a depth of 50%. Calculate the total power and the sideband power of the modulated wave. Here we are given the value of carrier power, that is 2 kilowatt, and the depth of modulation is 50%. So mu is 50 by 100, that is 0.5. We are asked to find the total power and also sideband power. Total power PT is equal to PC into 1 plus mu square by 2. Substituting for PC as 2000 into 1 plus 0.5 square by 2, we will get the value of PT as 2.25 kilowatt. Next is we have to find the sideband power. If we are given the total power and carrier power, then we can total power minus carrier power gives the sideband power. So total power is 2.25 kilowatt and carrier power is 2 kilowatt. So 2.25 minus 2, which is 0.25 kilowatt or 250 watt is the sideband power. Next question. The communication transmitter radiates a 1000 watt amplitude modulated signal and the modulation is done with a depth of 100%. Then what is the carrier power? Here we are given that the total power or the power that is transmitted or radiated is 1000 watt. That is PT is given as 1000 watt. And the depth of modulation is 100%, that is mu is 100 by 100, which is 1. Then what is the carrier power? We know that the equation of PT is equal to PC into 1 plus mu square by 2. Here the value of mu is 1. So PT is equal to PC into 1 plus 1 by 2, which is 3 by 2 into PC, or PC is equal to 2 by 3 of PT, which is actually written here. PC is 2 by 3 PT, or PT is equal to 3 by 2 of PC. Here we are asked to find the value of PC. So we are expressing PC in terms of PT. So PC is equal to 2 by 3 PT. PT is given as 1000. So 2 by 3 into 1000, which is 666.6 watts. Next question. If the modulation done with a depth of 100%, what is the relation between total power and carrier power? This is same as the problem which we have done just before. That is PC is equal to 2 by 3 PT. Option C is correct. Next question. The RMS value of a radio frequency voltage after modulation to a depth of 50% by a sinusoidal voltage of 80 volt. Calculate the RMS value of carrier voltage when amplitude modulated to a depth of 75%. Let us read the question once again. The RMS value of radio frequency voltage after amplitude modulation to a depth of 50% by a sinusoidal voltage of 80 volt. Here the depth of modulation is given. So 50 by 100, which is 0.5 is the value of modulation index mu. We are also given the RMS value, that is VRMS of amplitude modulated signal. That is, we are actually given the VT, the value of VT, that is 80 volt. And we are asked to find the RMS value of carrier voltage. We are asked to find VC. when modulation depth is 75%. That is when mu is equal to 75 by 100, that is 0.75. So first let us find the value of Vc. We know that the equation of power Pt is equal to Pc into 1 plus mu square by 2. Actually power is equal to power P is equal to V square by R. We have in previous class we have derived the current relations, that is P is equal to I square into R, and from that we have obtained the equation of current as It is equal to Ic into root of 1 plus mu square by 2. Similarly we can derive the expression for voltage also by substituting P is equal to V square by R. So instead of Pt, Vrms square or Vt square by R is equal to Vc square by R into 1 plus mu square by 2. Cancelling R and taking the square root, we will get Vt is equal to Vc into root of 1 plus mu square by 2. This is similar to current relation. You don't have to derive it. Just like current relation, the voltage relation is Vt is equal to Vc into root of 1 plus mu square by 2. Now let us perform the calculation. We are given the value of transmitter power as 80 volt. That is voltage after modulation. So it is what is given as the actual transmitted voltage. It is 80. So 80 is equal to Vc into root of 1 plus value of mu is 0.5. 0.5 square by 2. 80 into root of 1 plus 0.25 by 2. We are asked to find the value of Vc. So 80 divided by root of 1 plus 0.25 by 2, which is 75.42 volts. Now we obtained the value of Vc. But we are asked to find the RMS value of carrier voltage when modulated to depth of 75 volt. The actual question should be not the RMS value of carrier voltage, RMS value of modulated signal, RMS value of voltage after modulation. So what is actually asked is Vt. We know the value of Vc. We calculated it just now. So Vt is equal to Vc into root of 1 plus mu square by 2. Here the value of mu is 0.75. So let us substitute for Vc as 75.42 into root of 1 plus 0.75 square by 2, which is 85.37 volts. This is the modulated carrier RMS voltage. Next question. An AM broadcast transmitter has an antenna current reading of 32 amps. But after modulation, it increases to 35 amps. Calculate the modulation index. This is actually the current relation. That is, It is equal to Ic into root of 1 plus mu square by 2. We are given the value of Ic as 32 amps, It as 35 amps, and we are asked to find the value of mu. Here, in this derivation, we know that It is equal to Ic into root of 1 plus mu square by 2, and rearranging we will get the value of mu as root of 2 into. Here there is a bracket is missing. This 2 is common for It by Ic the whole square minus 1. 2 into, within the bracket is the first term and 1. Then you will get the value of mu as 62.7%. Next question. The AM broadcasting transmitter has an antenna current of 50 amps and it is modulated by depth of 50%. Then what is the carrier signal reading? Here we are given the transmitted current as 50 amps and modulation index is 50 by 100, that is 0.5. We are asked to find the carrier signal current. So Ic is equal to It by root of 1 plus mu square by 2. Substituting the value of It and mu, we will get the answer of Ic as 47.14 amps. Next question. Determine eta, that is modulation efficiency, and the percentage of total power carried by the sidebands of AM for singleton modulation when mu is 0.5. First question is when mu is 0.5, value of eta. Value of eta is mu square by 2 plus mu square. Mu is given as 0.5. So 0.5 square by 2 plus 0.5 square into 100. It is 11.11%. Similarly, when mu is 0.3%, the value of eta is 0.3 square by 2 plus 0.3 square into 100, which is 4.3%. This is direct substitution type problem. You just know, you should know the value of eta. Eta is mu square by 2 plus mu square, modulation efficiency square into 100. Next question. A broadcast transmitter radiates 10 kilowatt of modulated power when carrier power is 9 kilowatt. Is modulated by a sinusoidal voltage. Calculate the modulation index. Here we are given the transmitted power or radiated power as 10 kilowatt. That is PT is 10 kilowatt, PC is 9 kilowatt. Then we are asked to find the value of modulation index. On substituting, 10 is equal to 9 into 1 plus mu square by 2. On rearranging and substituting the value, we will get the value of mu as 0.471. Next question. The message signal with frequencies 10 kHz, 15 kHz, 20 kHz, 50 kHz are amplitude modulated by carrier signal. Then what is the bandwidth of the transmitted signal? Here we are given 4 frequencies, and it is said that they are amplitude modulated by a carrier signal, and we are asked to find the bandwidth of the transmitter signal. We know that the bandwidth of the transmitted signal, this is a case of multitone modulation, and in multitone modulation the bandwidth is equal to 2 times the highest frequency component in the message signal. So 2 into highest frequency is 50 kHz. So 2 into 50, which is 100 kHz. This is the bandwidth of the transmitted signal. Next question. In multitone modulation, several sinusoidal signals are modulated with modulation index of 0.3, 0.5, 0.4. What is the total modulation index? There are 3 modulation indexes, and in case of multitone modulation, the total modulation index mu t is equal to root of mu1 square plus mu2 square plus mu3 square. That is 0.3 square plus 0.5 square plus 0.4 square. 0.3 square is 0.09, 0.5 square is 0.25, and 0.4 square is 0.16. On adding, we will get square root of 0.50. Now let us solve it. In the option, the answer may be not root of 0.5. So let us write root of 0.50 as root of 50 by 100. 50 by 100 is 1 by 2. That is root of 1 by 2. Let us rationalize it. That is multiply numerator and denominator by root 2. So root of 1 by 2 into root 2 by root 2. So the answer is 1 by 2 into root 2, which is 1 by 2 is 0.5. So 0.5 into root 2 is the correct answer. Next question. A carrier signal C of t is equal to 20 into cos 2 pi 10 raised to 6t is modulated by a message signal having 3 spectral components, 5 kHz, 10 kHz and 20 kHz. The corresponding modulation index are 0.4, 0.5, 0.6 respectively. Calculate the bandwidth and power. Here we are given there are 3 set of frequencies, and also the carrier signal is given, and we are asked to find we are also given the modulation index of 3 frequencies, and we are asked to find the bandwidth and power. Bandwidth is always twice the highest frequency component. Here the highest frequency component is 12 kHz, and twice of that is 40 kHz is the bandwidth of the transmitted signal. Now the equation of power is actually PT is equal to PC into 1 plus mu t square by 2. So first we have to find mu t. Mu t is root of mu1 square plus mu2 square plus mu3 square. We will get the value as 0.8774. Now let us calculate the value of PC. PC is equal to AC square by 2R. Here the value of resistance is not given, so we are taking it as 1. That is normalized resistance. So AC is, from the equation of carrier signal, equation of carrier signal is AC cos 2 pi FCT. So the value of AC is 20. So 20 divided by 2 into 1, that is 2. So 20 square by 2, which is 400 by 2, 200 watt. Now let us substitute for PC and mu T square in the equation of PT. We will get the value of PT as 277 watt. Now we have to find the sideband power. Sideband power is total power minus carrier power. 277 minus 200, which is 77 watt. Now we can move on to the next. You can note down, this is a note, the limitation of envelope dictator. Envelope dictator is used to demodulate the AM signal, and the limitation is that the value of RC constant should lie between 1 by FC and 1 by FM. 1 by FC should be less than R1C less than 1 by FM. For demodulating the over-modulated signal, which type of demodulators are used? For demodulating over-modulated signal, synchronous dictators are used. Next question. The advantage of AM. Advantage of AM is that the receiver is very simple, and the disadvantage is that most of the power is wasted in carrier. That is, power taken by sideband is very, very low. Next question. Next is actually the application of AM. They have written as limitation of AM. It is actually the application of AM. AM is used in point to multi-point communication. That is used for broadcasting of signals. Then the second application is that they are used for audio signal transmission. Next question. Amplitude modulation is used for broadcasting signal because it avoids receiver complexity. That is, receiver is very simple. So AM is used for broadcasting. AM is used for broadcasting because receiver complexity is reduced or avoids receiver complexity. Next question. The modulation index of an AM wave is changed from 0 to 1. Then the transmitted power is, it is given that the value of mu is changed from 0 to 1. Then what will be the transmitter power? So when the value of mu is equal to 0, PT is actually PC into 1 plus mu square by 2. Mu is 0. So PT is equal to PC. And when the value of mu is 1, the value of PT is PC into 1 plus 1 by 2. 1 plus 1 by 2 is 1.5. So 1.5 PC. So the value of PT changes from PC to 1.5 PC. That is actually 50% increase. So the answer is option D, increase by 50%. Transmitter power is increased by 50% when the value of mu is changed from 0 to 1. Next question. The AM wave is given by V of t is equal to 10 into this cos 2 pi FCT. Then the highest frequency of the message signal is, this is a signal, it is actually a multi-tone modulated signal. So the equation of multi-tone modulated signal is AC into 1 plus m1 of mu1 into cos 2 pi fm1t plus mu2 into cos 2 pi fm2t plus mu3 into cos 2 pi fm3t. Total into cos 2 pi FCT. So the highest frequency of the message signal is actually, the highest frequency present here is 10 raised to 5. So 10 raised to 5 is the highest frequency of the message signal, but it is not given in the option. Let us represent it in terms of kilohertz. That is actually 100 kilohertz. This is the highest frequency of the message signal. Next is bandwidth of AM signal. Bandwidth is always twice the highest frequency. Highest frequency is 100 kilohertz, so twice of that is 200 kilohertz. So the answer is 200 kilohertz. Next is modulation index. We are given from the equation, we can see that value of mu1 is 0.5, mu2 is 0.4 and mu3 is 0.3. So modulation index mu t is root of mu1 square plus mu2 square plus mu3 square, that is 0.5 square plus 0.4 square plus 0.3 square. This we have done before, and finally the value is equal to 0.5 into root. Next question. The modulation index of AM signal is 100%. What is the percentage of carrier power in total power? Modulation index, percentage of modulation is 100%. So mu is equal to 100 by 100, that is 1. When mu is 1, what is the percentage of carrier power in total power? PT is equal to carrier power, PC is equal to, if the value of mu is 1, then we can express PC is equal to 2 by 3 of PT, that is 2 by 3 of 100, that is 66.6%. So 66.6% of the total power is the carrier power. So in today's class we have discussed some questions related to amplitude modulation. If you're having any doubt, you can comment below. We can see more questions in the next class. Thank you.